All right. Don't forget, if you did the extra credit, make sure you send it to me. Had a couple people get, so actually everybody who did it got at least one of them right. And Jamie got a couple of them here, so send that extra credit in. Let's go to review the formulas that you would have needed in the extra credit last night. The first formula that I gave you was the formula to find arc length. What is that formula, Chris?
S equals V over T.
It's not the formula I gave you specifically for arc length, though.
S equals R theta rad.
There we go.
R theta rad.
How about just R theta rad? There we go. S equals R theta rad was the first equation that I gave you. And then from there we talked about linear velocity. And what was that equation, Quentin? That was the second equation that I gave you. Kind of was an extrapolation of the first two. So Jamie?
V equals S over T.
Good, S over T. So V equals S over T was the first equation. And we said, well, because S is R theta rad can go in for the S. And one important thing, because theta has to be in radians, if you have degrees and need radians, remind us what we do, Ethan?
You divide or times by. You need radians?
I need radians.
Pi over 180.
Good, multiply by pi over 180 degrees, and that'll get you the radians, since a lot of times we're given degree values. I want you to be practicing with these formulas on numbers, page 47 to 48. I want you to work on numbers 18, 20, 24, 30, 34, and 36. Again, that's on pages 47 to 48. Work these 6 problems practicing with these formulas. Take about 4 minutes-ish, and then we'll take a look at these answers together. Make sure you have these formulas memorized. Sounds like geometry all over again.
I have a question.
Yes, sir.
Linear velocity is V equals S over T, right?
Correct. Or R theta rad over T, depending on what you
I got a weird number.
It's okay. Weird numbers are allowed. Chris is finished. Okay, about 30 seconds longer. For sake of time, put your pencils down and let's take a look at these together. Number 18, they give you an arc length of 1.2 kilometers and a time of 1,080 seconds. I told you I want what units for my linear velocity, Jamie?
Meters per second or feet per second.
Right, so since they gave me kilometers, I'm going to want to change that into?
Meters.
How many meters is 1.2 kilometers?
1,000.
1,200, right? Move the decimal 3 places. And so we're going to simply divide arc length divided by time. And when we do, we get what for our velocity?
1.1 meters per second.
Good, 1.1 meters per second. Dropping down to number 20 right below it. They already gave us meters. They gave us seconds. We just divide. Chris, what do we get? That's 2 sig figs.
9.
We lost. Okay, 9.80. And then what's our unit?
Meters per second.
9.80 meters per second. By the way, it's not G, that'd be meters per second squared, physics class. But yeah, 9.80 meters per second. Dropping down to number 24, finding the linear velocity, again, r theta rad over t. And for number 24, they gave us theta as 90 degrees, but Ethan, we know that that's pi over 2. And then they also gave us 11 minutes, 3 seconds, Quentin. Let's change that to how many seconds? 663 seconds. Okay, so we've got our r, that's already in feet. Our theta, we'll change to pi over 2. We're going to divide by 663 seconds. That's a really long time. So this is a very slow linear velocity. What did you get for your answer on this, Ethan?
I got it wrong because I looked at the 11 and I added the 11 to the 660, so I had 671.
Oh, okay, gotcha. So you're going to be a little bit off then. Quentin?
1007.
Well, that's only 1 sig fig. This class we're at least going to have 2. I'm kind of going off 3 because 3.09 is 3 and 663 is 3. We kind of went exact with the pi over 2. So I'm going 3 sig figs here. I got 0.00732 feet per second. Does that make sense? Okay. Questions on 18, 20, or 24? Any questions on those first 3? All of those really largely straightforward because they used the equations as given to you. Now the rest of these, we're going to have to manipulate the equation a little bit to get what we want. Number 30, it says to find time given S and V. And so if I want to find the time, what am I going to have to do, Chris?
T equals S over V.
Good, alternate to get T equals S over V. And we'll take the arc length that they gave us, which you say, well, that's in centimeters. Yeah, but so is the velocity. It's in centimeters per second. So leave the units as they are. Allow the centimeters to cancel themselves to get what answer?
You're on number 34?
Number 30.
Oh. 2.365
Good, and the time, of course, measured in
seconds.
2.365 seconds is correct. Look at the next page, number 34. Finding time given r, theta, and v. Okay, so ignore this part of the equation here. Finding the time given r, theta, v. How do I solve for time here? Jamie?
You switch the T and V.
To get?
T equals r theta rad over V.
Good, r theta rad over v. And r is already in feet. Theta's degrees, but class 180 degrees is what?
1 pi.
Just pi, right? So pi becomes the theta rad, and the velocity is already in the feet per second, so the feet and feet will cancel. What do we get for our answer on this one, Jamie?
368.49 seconds.
Okay, how many sig figs? If we assume pi is exact, that gives us either
30
or 2.085 would be 2 sig figs, right?
Right.
Picking number 34. So again, assuming pi is exact, don't worry about that number, but take the r and the v. Go 2 sig figs on your answer.
370.
Good, and it's time, so
Seven.
there we go, 370 seconds, our answer for 34. And then Ethan, number 36, we're finding the radius given time, theta rad, and velocity. So on number 36, how do I rearrange the equation for the radius?
You pointed the R.
Yeah. How do I solve for the radius? Get the radius by itself.
Move it over, well, when you divide or times the theta rad away.
All right, so let me take out the middle band and just boil it down to what we want here, okay? So you gotta learn to mentally ignore stuff, kind of like, in a basketball game, you gotta ignore or tune out the noise around you, okay? Focus just on that front hook of the rim as you're releasing the ball. But try to get the R by itself here.
So you could like alternate as TV equals R theta rad, and then divide the R away.
Well, I want the
So
R.
TV over R.
I want the R.
Divide the theta rad.
Divide the theta rad away. There we go. And that'll get the R equals TV over theta rad. Again, we're not going to memorize this. Okay? We don't have room in our brains for all of these different formulas. We're just going to memorize these, right? But be able to manipulate them effectively. So I'm going to take the time, which is in seconds already. We've got the theta rad, which is pi over 3. Now, they gave us a velocity in centimeters per second. You know what that means? My radius is going to be centimeters. That's okay. They're going to give me weird units. I'll take them. So we should get our answer in centimeters. Might have gotten into meters. What do we get for our answer, Ethan? As a plane roars by overhead. My so many GPSs recalculating.
5357.
Not quite what I had. Quentin? 5.36 E3 centimeters, or 5,360 centimeters, or if you went meters, 53.6 meters would have been correct as well.
That's what I had. I just didn't do what he did. Like, I had 5,357.9.
Oh, 5,357. Okay, I misheard what you read.
5,357.
Gotcha. Yes. So you just didn't round up to the third sig fig. All right, that is correct then. Good. All right, questions on these? Questions on the formulas that I taught yesterday and the day before. Do we feel like we understand these? All right. Let's take a look at a couple word problems then. Look down at word problem 41. Read that for us if you would, Quentin.
A horse runs exactly 2.5 laps on a circular track with a diameter of 880 yards. At an average velocity of 20 miles per hour, how many minutes does this require? 1 mile equals 1,760 yards.
All right, circular track. You don't see a whole lot of those, but hey, this makes the math work better. So we're going to pretend there's such a thing as a circular racetrack. Diameter is 880 yards. That line over the 0 just means the 0 is significant. That's the old way of showing sig figs. 880 point yards is the diameter. Though, do we ever really use diameter in any of our math? Doesn't seem like it. So let's change that to the radius of 440 point yards. Okay, so there's our radius, 440 point yards. It says he runs 2.5 laps. Every time around is what?
80 yards.
No. 360 degrees, but every time around is 2 pi. He goes another time around, that's another 2 pi. And then he does a half lap, which is, so what is 2.5 laps? 5 pi. 5 pi is the
Distance or
pi radians. It's a way of measuring what? Angles. 5 pi is his angle, which would be theta rad. So 5 pi is our theta rad. That's the angle he runs around the track. It's 5 pi, 2.5 revolutions. Our radius of 440 yards, we said. And it says that with an average velocity, obviously that's going to be
20 miles an hour.
V, right, of 20 miles an hour. Oh, little problem, 20 miles per hour. Now, the question is, how many minutes does this require? So my answer of time is going to be in minutes. Minutes doesn't jive with hours. Furthermore, the radius is in yards. Yards doesn't jive with miles. So let's change this here, my 20 miles per 1 hour, and let's use dimensional analysis to change this into yards per minute. They give me one important number, Chris, and that is that a mile is 1,760 yards. So how do I set that up in the fraction?
1760 yards, 1 mile.
Over a mile, and that gets the miles to cancel. That's yards per hour, but I want yards per minute, so Ethan, how do I go from hours to minutes?
You 6 minutes is 1 hour, so put 1 hour over 6 minutes.
Good, we're gonna put the 1 hour over the 60 minutes so that the hours cancel, leaving me with minutes. And so at your seats, just multiply, then divide the 60. And what do we get for the velocity?
586.
Evenly?
0.6 for
Repeating, 586.6 repeating? All right, tell you what, keep that in the memory of the calculator perhaps, or be prepared to type a lot of 6's in. Okay, so let's just put that in the memory, though I think that'd be easiest. And what equation that we are memorizing relates these 4 variables together? Back to Quentin. Good, v equals r theta rad over t, but I'm solving for the time. How many minutes does it take him? So I need to get t is equal to r theta rad over v. We have our r, we have our theta rad, we need to multiply those and then divide away the v, which is in the memory, to get how many minutes for his 2.5 laps.
345.5 seconds.
Ooh, that is not what I have.
11.78.
11.7, I assume it keeps going, right?
80.
Okay, so how many sig figs are we on the cloud? I've got 3 here, I've got 2 here, so 2. So we'll say, well, 12. So in other words, this was the horse's 12-minute run. He did 2.5 laps. But the track was way bigger than our PE field, so. Questions on this? Brings back good memories, doesn't it, Ethan? No. All right, questions on number 41. Then let's take a look at number 42. And read this one for us, if you would, Chris.
Roller coaster is built so that section of the track has many identical circles circular horizontally loops. The loops are 152 feet in diameter. The roller coaster travels at 42 miles an hour. Through how many complete loops will the roller coaster travel at 46.5 milliseconds?
All right. At least the horizontal loops. I mean, I can handle horizontal loops okay, I think. It's just the vertical loops. Like, I don't do upside down and my stomach goes upside down, and I don't do that. Personally, if you enjoy roller coasters, more power to you. I'm like, my stomach doesn't need that in its life. But anyway, lots of identical circular loops. 152 feet in diameter. Thoughts? 76 foot radius. Okay. 42 miles an hour.
Conventional analysis.
Right. That's my velocity. Starting out 42.0 miles per 1 hour. And what units do I want?
Feet per second.
I want feet, and later it mentions seconds because it gives me a time of 46.51 seconds. So apparently I want feet per second. I'm going to go from miles per hour to feet per second. Give me a fraction here, Jamie.
1 hour over, is it 3,600 seconds?
3,600 seconds. All right, so that's miles per second. Quentin, give me another number, another fraction.
5,208 feet per 1 mile.
And just like that, we're going to have our feet per second. I don't think it works out evenly. Maybe it does. Multiply, divide. What do we get?
61.6.
Evenly? Hey, I like that. That means I don't have to use it in memory. 61.6 feet per second. All right, so I've got my R, my V, my T, and it says, how many circular loops will the roller coaster travel? Well, a loop class is
Circle.
2 pi. So the question is, how many 2 pi's? Well, that means how many radians? I'm finding theta rad. So, again, what equation relates these variables, Ethan?
V equals R times theta rad over T.
All right, and if I want to get the theta rad by itself, what do I need to do? TV over R.
Good. Theta rad.
So take the T times the V, divide by the R, that'll give you your angle in radians. And what do we get? 37.69 exactly?
Blah, blah, blah.
Blah, blah, blah. Now that's how many radians, but it didn't ask how many radians, it said how many loops. And again, one loop is what?
2 pi.
2 pi. How many 2 pi's? How would I figure out how many 2 pi's that is?
Times by pi.
Divide by 2 pi. So take that, divide by 2, divide by pi, or if you're Ethan, you can divide by 2 pi. And how many loops?
0.6366.
Oh, careful.
5.999.
5.999, basically almost exactly 6 loops. In fact, if we went to, is it 3 sig figs? 3, 4, 4, 3 sig figs. If we go to 3 sig figs, I believe it's 6.00 loops, right? So 6 loops in 46.51 seconds. I'm pretty sure that 46.51 was intentional to give you as close to exactly 6 as possible. But questions on that? All right. Next thing in your notes, I want you to write this down, angular velocity. Angular velocity. Angular velocity and linear velocity are not entirely the same thing. Angular velocity is defined as rotation per unit time. Rotation per unit time. For instance, as I stand here facing at you, I could rotate 90 degrees. Pi over 2, right? And if it took me 2 seconds to do that, that's pi over 2 radians in 2 seconds, rotation divided by time. And that's literally our equation for angular velocity. We're going to represent it with the Greek lowercase omega, which looks like a W, is equal to theta rad over t, rotation per unit time. And our units are per second. Or, if that really bothers your soul, I'll allow you to put radians per second. Technically, though, a radian is unitless. So, omega equals theta rad over t. Think about this, though. Rotation per unit time. Theta rad over t. Linear velocity, remember, is displacement or distance over time, right? R theta rad over t. So if v equals r theta rad over t, and omega is theta rad over t, then v must be r omega. So 2 more equations for you. That makes a total of 5 equations for this section. 5 equations to know. Angular velocity, rotation per unit time, is just theta rad over t per second for your unit. But if you wanted a linear velocity, you could multiply the angular velocity times the radius. How fast is the object spinning? For instance, you're on a merry-go-round, for instance. If you're standing in the middle of the merry-go-round, you have no radius. So even though it's spinning, and you are spinning, you've got a rotation per unit time, you're not going anywhere. If you're further out, though, now you're going around in circles, and you are going somewhere, right? I'm going to stop there, because I'm too old for this, but I don't do merry-go-rounds anymore. Right, you take the radius times the angular velocity, and the further out you are, the faster, literally, you are going to keep up with the whole merry-go-round, right? So the idea is, if you're like me, you stand in the middle. And if you're young and adventurous and full of spirit, you stand as far out as you can and puke. I don't want to be around for that. But anyway, questions on these equations. Does that make sense? So this is arc length per unit time, or distance per unit time. That's linear velocity. But if it's asking for a spin rate, if you will, or a rotation per unit time, that would be your angular velocity. For instance, the automobile engine, RPMs, revolutions per minute, right? Okay, that's what we're talking about. That's a spin rate. That's an angular velocity, if you will. Look at page 49. Look across the page, page 49. Look at number 48. It asks for you to find the angular velocity. Well, angular velocity is defined as what per unit what, class? Thank you, Quentin. Rotation per unit time. How much rotation takes place in number 48?
24.5 years.
On number 48, how much rotation takes place?
Pi.
180 degrees.
180 degrees. But we need to call that, I think Quentin just said it, pi. So for omega, we're going to say that that's pi radians per unit time, which is,
78.11.
oh, we need it in seconds. So what do we do with the 78.11?
5 by 60.
Not 5 by 60,
Nine.
times 60. That's a whole lot of seconds, right? How many seconds is that?
It is
46,000.
4,686.6.
That's a whole lot of seconds to only go half a rotation, right? It literally takes 78 minutes to go from here to here. Very slow rotation, right? So, if it's very slow rotation, we should expect a very small number. And what do we get?
6.7 e -4.
I like the use of the scientific notation there. Yeah, 6.7 e -4 or 0.00067 per second. Or you could say radians per second if it really bothers you to just say per second. Questions on that? See how easy the equation is?
Yeah.
Make sure it's radians divided by the time in seconds. Look at numero 50. They want the linear velocity. They give you the angular velocity and they give you the radius. They want the linear velocity. But look at the radius. 16 centimeters? What do I want it to be? Meters, because I want velocity to be meters per second. If this is in centimeters and this is your radians per second, or we could just say per second, that's going to be centimeters per second. I want meters per second, so change your radius to meters. 0.16, careful, two places the other direction, 0.160 meters. And then your omega is already in radians, right? 3 pi over 2 radians per second, so just multiply. What do we get? I do the 3 pi over 2 first, get that value, then multiply the 0.160.
0.7539.
Good, we'll round it to, looks like 3 sig figs.
0.753.
0.754
7.564.
meters per second. Does that make sense? Questions on that? Looking at number 56, finding the angular velocity. So we know how fast this object is moving. It's going 65.5 meters per second, which is really, really fast. The radius of this circle around which it's going only has a radius of 21.1 meters. So how fast is the entire object, if you will, how fast would the object be rotating? How rapidly rotating? How much rotation per time, or revolution per time, we could say?
You said problem which one?
56. Pay attention, please. We're finding the angular velocity here. So how do I get omega by itself? Divided by the r. V divided by r. So plug it in. V divided by r. What do we get?
3.1.
Good. 3 sig figs, 3.10. And since it's omega, per second, or radians per second if you'd rather. Look at 58. It says find the angle of rotation. How do I represent, what symbol represents angle of rotation, class? Theta rad. Okay, so I'm finding theta rad. Notice they give me time and they give me omega. What equation relates theta rad, time, and omega?
W equals
Omega, not
omega.
W.
I know.
Omega equals theta rad over t, but if I'm finding omega, class, how do I get it by itself? Omega t. Multiply omega times time, right? So you've got omega, you've got time, multiply them. Again, I would do the 17 pi over 2 first, then multiply the 1.5 seconds. And this is fun. What is the angle? How much rotation is there?
40.0553.
Let's go 2 sig figs.
40 point.
40 point what? Nothing. Just 40 point. You could say radians, that wouldn't be wrong. How much rotation? 40. And this is why all along, remember in geometry, so you got to put the degree symbol. Why? Because if you don't, you mean something very different, right? 40 degrees and 40 radians are way different. Okay, so 40 point is your angle of rotation, or 40 point radians. Drop down to 62. Find the time required. And notice what they give you. Theta, theta rad evidently, and omega. What equation relates those things? Theta rad over t. You're memorizing this, right? That's why we're saying it over and over again here. But we're solving for the time. So I need to alternate. So what's my equation? T equals theta rad over omega. You got the theta, you got the omega, divide them. Notice the pi's are going to cancel. It's going to work out really nicely. And what doth we getteth, forsooth?
30?
Nope.
62, right?
Remember 62.
22.5.
Ooh.
222.
Ooh, okay. So we're saying T is equal to theta rad
0.9.
over omega, right? So theta rad, it said, is 5 pi. And we're dividing by the quantity, 9 times pi divided by 2. I would use parentheses here.
1.1.
1.111111111. And here's the hard part. There's no sig figs. Everything's exact. If it's written in terms of pi, it's exact. So we don't know how many sig figs, but I do know what 0.1 repeating is. 1/9. So we could say 1 1/9 seconds for my time. Or 1.1 repeating seconds, because you can't round to sig figs, because there are no sig figs. Everything's exact. Kind of a weird problem there on 64. Excuse me, 62. Questions on that? Again, only 5 equations to memorize. S equals R theta rad. V equals S over T, which also equals R theta rad over T. Omega equals theta rad over T. V equals R omega. Those are your 5 equations, where V counts as 2, if you will. Be able to manipulate them, though, to get anything you want. Your homework for this evening is to do pages 47 to 49. Pages 47 to 49. Need you to do numbers 22, 26, 28, 32, 38, 46, 52, 54, 60, and 64. It's only 10 problems, so it's really not that bad. But it sounds like a lot because they're all picked, not entirely at random, they're picked actually strategically, but picked there. Make sure you know your formulas, because tomorrow is Friday. Just throwing that thought out there. Now, if you're watching on YouTube, it may not be Friday. For us, it's Friday, and that's significant. All right? You are dismissed. Have a wonderful rest of your day.